A year and a half ago, with the UK still under COVID restrictions, the SVR embarked on a brave new project. We wanted to convert this former diesel shunter into a heritage vehicle for the future. So we partnered with some experts in future technology, and the creation of the Hyria Hydra Shunter was underway.
This project's all about taking this locomotive, an existing locomotive, and making it ready for the future by providing it with a clean source of sustainable energy. The original concept was to take a bus power system, fuel cell, batteries, tanks, and put it into this directly. Unfortunately, we discovered that the bus components weren't quite right. The fuel cell too powerful, the battery of too little capacity. So what we've been doing since we last spoke is we've been working on finalising out the design. We've had to change a lot of things, but we're now approaching signing off all of the design elements. Certainly the challenge around providing the right equipment for this locomotive extended the schedule of this project, and it's also increased the amount of cost that was required, because obviously we'll have to get new equipment as opposed to using what we've harvested from the hydrogen buses. So I'm going to give you a quick talk through of the Hydra Shunter locomotive. Starting here at the back, we have two engine mounts. On top of this, we're mounting a 100mm thick steel plate, nice and heavy, for adhesive purposes, which we put all of our equipment on top of. Moving further forwards, there's going to be a great big lead acid traction battery here, weighs another 6 tonnes, useful for adding more adhesive weight to the rail, helps us shunt about. Right at the front of the locomotive, we're going to have our fuel cell and DC-DC converters. Purpose of the fuel cell is to charge up the battery. Purpose of the DC-DC converters is to convert the energy from the fuel cell to the battery, and also take the battery's energy and put it down to the traction motors. Finally, we're going to have an array of 12 tanks above our heads. These are arranged 3 wide by 2 high and 2 banks forward and aft, and that stores all of the energy we require to operate the fuel cell for a protracted period of time.
Well, it's certainly unusual. It's not the sort of thing you typically find at a heritage railway. It's like nothing else here in this depot. It's the first diesel to be converted to hydrogen, I think, in the UK. So I'm quite proud to be involved with this quite unique project. The Class 08 is a very commonly preserved locomotive. There are loads of them. We've got half a dozen of them here, I think. We've got plenty of accurate surviving examples. I think this was the ideal test bed to do a project like this. So I think the reaction will mostly be very positive to see that the railway's moving in a direction of trying to think about moving forward into the future, modern technology, and also environmental sustainability as well, which I think is a very important issue.
So this is a mock-up of the control panel. We've kind of prototyped what the control panel inside the cab will look like when we convert it to use a hydrogen hybrid power pack. So this is helpful to test it electrically and also to give driver familiarisation. So when you start the train up, you will use the key to switch the train on, like you would a car, essentially. And then this switch will help you change it between the 2 main operating modes. One of them is battery only, where we'll just use the traction battery to operate the train, so essentially like an electric car. Or there'll be a hybrid mode, where the fuel cell and the battery will work in tandem in order to help the peaks and the troughs of the train demand. And then there are a number of indications the driver will use, one of them being start up and shut down, which will just let the driver and crew know what state the locomotive is in, and so there's a bit of feedback from the system. And there's an LED to tell the driver when the system is ready, so they can begin to draw power and start to drive the locomotive. Here there are lots of safety systems, as you can imagine, with a locomotive using hydrogen as a fuel. Hydrogen is flammable, but there are a large number of safety systems to ensure this locomotive can be safely operated and can be reliably operated. There are LEDs and audible alarms for if there's a fire or there's a hydrogen leak, so the driver can take the appropriate actions. There's also a large traction system emergency stop button, which will shut down the traction system and make the whole thing safe if there was ever to be an incident. There are a number of different warnings, such as the battery level being low, or the fuel level simply being low. And then there's another pair of indications here, just to give the driver a bit more information if there was a fault. So one of which is if the traction system completely shuts down due to an issue, and one is a crawl mode, if the train has to limp back to a depot. And these gauges will tell the driver the hydrogen pressure in the tanks and the traction battery state of charge.
From my university life, this is something so different. I get to work on some sanding and painting, or as I was working today, filing down and cutting down some pieces of metal to size for use on the traction actual system. completely different set of skills, completely different scenario, completely different group of people, and it's fantastic to have that break from reality, I guess.
Today we've been mainly painting and things like that, so today we had Sam finishing off the red buffer beam, and then we've been filling and painting panels as well to make sure that they're ready for the top coat later on, hopefully this week or the next week. It's an amazing feeling knowing that I've helped turn it from what it was when we first started, when it was just all rusty and blue, to what it is now and what it will be later on. I think it's a great achievement by not just myself but by everybody involved in the project as well. I'm quite happy to be here, especially at this stage of the project, because knowing that you're not actually that far off it being finished, and I think when it moves we'll be very emotional considering the amount of time we've spent on it.
I'm feeling very happy and positive about this project. It's great to finally get to a design where we've confirmed that all the equipment fits, all the equipment works together, and I'm looking forward to getting on and building this thing.
The Hydro Shunter project has already had to overcome quite a few challenges, but the determination of our group of young volunteers and the experts from Vanguard are going to give the SVR the first hydrogen-powered locomotive in the UK. And fingers crossed, it'll be up and running by next summer.